Thanks for joining me, everyone. I'm Matt Lonstein. I'm the Director of SAP Technology at Symmetry. Get into a little bit of who we are and how we're situated in the space, give you some background. We were founded in 1996, and we started as an SAP technical managed services and consulting firm. Also do global hosting, specialize in cloud hosting specific to SAP environments, specialize in cloud hosting for SAP workloads. We have our own private cloud offering in 5 data centers, but we do also do support and administration of SAP environments and landscapes in the public cloud. Significant bench of basis consultants. Most of these employees are either technical consultants or engineers, and certified across a couple of different towers in the SAP space.
Fix that a little bit closer, sorry.
Nope.
There you go.
Cool. So in 2005, we launched our, essentially our cloud platform. We saw a lot of our customers moving into hosted environments and getting a rough ride, essentially. We had a lot of hosting background. We knew we had the expertise. We definitely knew how to care for and feed SAP landscapes. We decided to get into that cloud hosting space too, to give our customers a better, more robust, higher performing platform for their SAP landscapes. And that was really behind our venture into the cloud space. And we were one of the first in North America to do that. Specifically, at least in the SAP arena. Needless to say, when you talk about cloud hosting, the operating system is one of the central pieces and one of the central components, right? So operating system selection for us, in terms of what we deploy as a de facto standard and what we recommend to our customers, is really, really important. And SUSE Linux Enterprise Server has really been our de facto Linux platform of choice. Certainly for SAP product platforms, and most definitely for HANA as well. They were one of the probably the earliest player in terms of certified OS for HANA. And SUSE has been along for the ride with us on our cloud hosting journey and our SAP technical journey for quite some time. So I talked a little bit about our cloud. A big part of our SAP cloud revolves around HANA. We have a lot of customers running HANA in our cloud. The HANA component of our cloud environment is essentially a very large TDI deployment. Some of you may be familiar with the TDI model, sort of rolling your own HANA environment, if you will. I think a lot of customers are probably moving to that if they're not in a cloud or they're not in a hosted environment. If they're running SAP on-prem, you may very well be running your own TDI environment. Some of what we'll talk about here will be really germane and relevant to you if that's true, because you can take some of the takeaways from today and apply them to your own HANA deployments if you're spinning up, spinning down HANA VMs. So why are we talking about HANA? HANA, although in the grand scheme of things and given how rapidly things evolve, is certainly not a new topic, but it does represent a little bit of a different way of thinking when we talk about securing an SAP product platform. Its surface area in terms of vulnerable vectors is probably a little bit larger, certainly than traditional database. Obviously HANA is much more than that. It can be a web application server, it can be a data mart, it can be a development platform. It's so much more than just a database. And by way of that, more surface area, again, to think about securing. And when you think about securing an application, a database, anything in the SAP realm, it starts at the operating system, where certainly the operating system is a central component, right? If your operating system is not secure, nothing above it, nothing above the OS and the stack is secure. For a lot of customers that I talk to who are deploying HANA on their own prem, it's not only is HANA new for them, but it might be their first foray into the Linux world. I do, believe it or not, talk to customers who have no Linux in their environment prior to deploying HANA. So some of the considerations and some of the maturity that they have in other spaces in their IT ecosystem, they don't have at their fingertips when they start thinking about Linux. A big part of the reason why we're here talking about this today. So when we talk about OS security, what are we really talking about? By no means is this a comprehensive list, but it's a pretty good high-level look at some of the main bullets that we want to think about when we talk about operating system level security, auditing and logging, software and patching, daemons and services, permissions, the network stack as it pertains to the internal mechanisms of the OS, and of course system access. Package selection. When you are deploying a server operating system, especially something that's going to support or run an SAP platform, in this case HANA, less is more. Install only the packages you need, right? That means that down the road, you'll have less to maintain, you'll have less to patch, and again, that vector of exposure is smaller, right? Because you have a very focused, considered set of packages that you've deployed, only what is absolutely required to either run your application, run HANA, or to support it. I do refer to this note. This note over time has changed a little bit, and right now it is essentially just a holding place for reference to a lot of other useful notes. So I do still reference this one specifically, although if you go and read it, you'll find it's not very long. But the manifest of other notes that are relevant and applicable is really useful. It's a good collection. It's summarized here. As you think about securing HANA with SUSE, you'll certainly want to familiarize yourself with some of the native functionality and some of the native tools available in SUSE Linux Enterprise Server. Zypper is the native and embedded backend repository and package management tool. If you're already running, SUSE today in your environment, certainly your engineers, your admins are familiar with this tool. It's actually pretty flexible, pretty powerful, a good sort of embedded and very accessible way to manage package deployment. This is actually a screenshot of some Zypper output showing essentially some packages or versions of packages that are deployed on a SLES VM, showing the repositories they come from. You'll want to familiarize yourself with Zypper, and there are flags and arguments that you can add to Zypper commands specifically in the arena of security to help you kind of identify and manipulate security packages. YAST is another embedded tool in SLES Linux distributions. It has a graphical component. If you've got Linux VMs running in run level 5, you can use the graphical version of YAST, but it can also be invoked on the command line. Even on the command line, it does use the curses library to build something like a menu-driven looking utility, even if you're working inside the shell. That is also a native and built-in tool. One that is not native and built-in, but I personally think is fantastic for patch management, is SUSE Manager, which is a standalone platform used specifically in a variety of capacities, to be honest. Patch management, one of its primary strengths. The reason that I really like SUSE Manager is the ability to define sets of patches and roll those versions consistently, waterfall them from upstream to downstream, right? You can do that with Zypper if you're creative and you have the know-how and you've got someone in-house who's good at shell scripting. That can be done with Zypper, but SUSE Manager is built for that, designed for that, amongst a lot of other cool functionality. Who in the audience would say that they have a mature patch strategy when it comes to patching the OS underneath SAP? It can honestly be a little bit of a different thing, right? When you're talking about patching an operating system underneath an SAP product platform, and again, in this case, HANA, it can be difficult because truly who owns those systems? The business, right? Businesses don't like downtime. and frequently patching requires that. So it's important, especially as you start to adopt HANA, where rebooting an OS, if it would be necessary in order to patch, can be disruptive. It might be downtime. You want to establish that cadence and understand what you're trying to achieve when you patch. Are you focusing on all needed patches? Or are you focusing specifically on security? How frequent will those iterations be? And get buy-in from the business early. This is really, truly not something you can neglect. And when we talk about patching being disruptive, I do have another slide that touches on that point. I'll move on and talk about that in a little bit. There we go. All right, so it's my next slide. When we talk about patching being disruptive in a Linux environment, the most disruptive component to patch traditionally in the Linux world is the Linux kernel. You guys might be familiar with the SAP kernel. Well, Linux has a kernel as well. All operating systems do. It's the way that the operating system interacts with the underlying hardware or with a virtual machine. And in consideration of security patching, the kernel is very important, right? It is essentially the guts of an operating system. It's important to keep your kernel current from a security perspective. But again, like I said, traditionally, patching the kernel, it requires a reboot, right? And if we're talking about a 4 terabyte HANA system running underneath S4, you know, the reboot of the OS may not take very long, but bringing that HANA system back online, bringing the column store content back into the memory image, the row store, right? Getting that HANA system back up and online and accessible and available to users is not always fast, right? That's why businesses push back on patching. Typically not because they don't think it's important, because they can't tolerate the downtime. Well, SUSE has a technology that allows you to patch the Linux kernel live kernel patching, right? And what that means is that when you are patching the Linux kernel in SUSE Linux Enterprise Server, you are essentially linking those patches, whether they're modules or some other type of additive component to the kernel, linking them to the running kernel. The kernel never stops. There's no disruption to HANA running on that, Linux VM, if that's what we're talking about, right? You can continue to apply those patches live to the running OS and stack those patches for up to a year without needing to reboot. I can tell you, from the standpoint of working for a cloud service provider, that is incredibly powerful. It is a really, really cool technology. There are a few implementations of technology like this. SUSE is theirs. They developed essentially their own technology and methodology for doing this themselves. It's called Kgraft. If you're so inclined and geeky enough, you can go out there and find quite a bit of information on it. I think it's fantastic functionality and a very, very good fit for HANA environments. We talked about securing HANA starting at the OS level, of course. SUSE Linux Enterprise Server has achieved a lot of security certifications. Go out there and do the research. You'll see them and find that it's pretty highly regarded in terms of its security. The YAST, and in this case the YAST2 utility, does have a security module that allows you in a menu-driven way to go through, itemize, and configure a lot of security settings that are relevant to the operating system. That module, I think I have a screenshot of it. I'm coming up on another slide here. It's fairly comprehensive. There's a lot there. I won't dive into all the bits and bytes of that. We could probably talk about that module, that security module, for 20 minutes on its own. But do be aware that it's there and it's available for your use. Makes consideration and thinking about security at the OS level under HANA maybe a little more accessible, rather than you having to go through and do all the research and compile those lists and your game plan all on your own. The SUSE security checker is something else that I've really grown to appreciate and I like a lot. The security checker is essentially installed with Zypper, the repository and package management utility embedded in SLES. And I believe the package is called SecCheck. And what SecCheck does is install some binaries, some programs, some configurations, some libraries, and schedules their use through cron. If you're familiar with cron, that's the native scheduling engine inside of Linux, and does a number of checks, daily, weekly, monthly, looking for secure configuration or deviations from secure configuration in your environment. Just for example, it will look at your etc password file, which is essentially the file that manages your operating system level users, and it will run a cracking utility against that file. If it finds that you have weak passwords, it will alert you to that, right? Those cron jobs will generate output. Typically they go to root's inbox. You want to redirect root's inbox to go to one of your security engineers or one of your senior administrators. They want to be checking the output that is going to be generated through cron by SecCheck. Checks for SUID and GID bits on files and directories, things that are inherently secure and that tend to accumulate in a Linux server over time. SecCheck does a very good job of checking. Especially useful if you have a lot of engineers climbing around in your servers who have different ideas of what is secure and what isn't. Helps you to maintain a standard, certainly. So this is a look at the security module in YAS 2. I know I mentioned that this does have a fully fledged sort of a GUI version, if you will. I'm still a recovering Linux geek, and so I like to do everything on the command line if I can. And even if you launch this on the command line, like you said, using the curses library, you'll see that it does sort of build up into a menu-driven utility. You get a little bit of a look at some of the things that you can iterate through and check and configure through YAS 2. Each one of these high-level items over here then pertains directly to the granular subset of the list. Definitely encourage you to take a look at this if you're running SLES in your environment. The SAP HANA Firewall. Just about every modern operating system out there today has its own native firewall capability, right? You can enable a firewall on Windows or on Mac OS running on your laptop, and the same is obviously true for servers. Traditionally in the SAP world, just about everyone has those firewalls disabled, right? Why? Because given their base configurations, they tend not to play nicely with applications and databases. That is where SUSE's implementation of an SAP HANA firewall is really different. It considers all of the needs and all of the technical components, the underpinnings of HANA, the ports that it utilizes, the communication that it needs to participate in a typical landscape, and they've made their firewall essentially smart and aware of HANA and how it runs, how a firewall might need to be configured in front of a HANA deployment. Predefined SAP HANA services certainly works with multi-tenant. So if any of you are running HANA 2.0, you likely have multi-tenant database containers. Works well in that environment. Definable service definitions. You might be asking yourself, why would I deploy a local firewall on a VM? Well, if you're limited in terms of what you can do in a DMZ, if you're highly regulated in terms of how your SAP landscape is situated and segregated, even if it's an internal network, it's there for you to use, and it's a pretty intelligent implementation. Some quick takeaways, some quick wins here. Again, by no means a comprehensive list. If we wanted to get comprehensive, I could spend hours talking about this, and this list would be thousands of bullet points. But these are some common things that I see people deviating from that are relatively easy to configure. Don't allow root access via SSH. I see this all the time. I see customer environments where people are logging in directly as root over SSH. That's an auditing nightmare, and there's no limit to what you can do inside Linux as root. Don't allow that. Force your users to log in with named accounts and they can elevate their privileges as need be once they're logged in. Makes auditing a much more sane activity. Configure root user mail forwarding. Do that especially if you are using SecCheck. Because remember, SecCheck and cron are going to push all of their outputs and the results of all their checks to root's mail. So make sure you're pushing that to a mailbox that's being actively checked by one of your engineers or security consultants. Use a central syslog server. Okay, you don't want to collect OS logs that might contain critical information, security sensitive information. You don't want those residing locally on the OS. You want to push those to a central location where they can be managed and protected. When they live on the OS, if the OS is compromised, then the logs can be manipulated and changed. People can cover their tracks. There's all sorts of nasty things that can result from that. Whitelist users who can use cron and at. Cron and at, again, native scheduling, right? You can imagine what happens when people, or what has the potential to happen, when people have free reign to the cron and at scheduling engines. Anything can be scheduled, right? A shell script masquerading as a standard program or a standard configuration. You can whitelist cron and at with essentially these two ACLs. They're not complex to configure. Take the time to do it. Easy to do. You can increase the security of your environment significantly just by taking 10 minutes to do that. Modify your default UMask, which essentially manipulates the default security mode on files and directories that are created by users. By changing the default UMask to 077, you're essentially taking read, write, and execute away from anyone who is not the creator of a file or directory. Permissions.local is another config file where you can essentially itemize and identify a list of critical files, critical directories, critical configuration at the OS level, and apply a specific set of security considerations to that list. Definitely something I would recommend you looking into. And implement your secure syscontrol variables. Syscontrol essentially manipulates the kernel and the way the kernel behaves with the operating system's network stack. There are a ton of variables that can be changed using the syscontrol utility. And for HANA, a lot of these pertain to network and communication flow. Those are particularly important to pay attention to. Covered by a number of SAP notes. You'll find them out there. I can even generate a list of those notes and share them with you. I'll give my email address to anyone who's interested, and we can kind of continue the conversation that way. So in short, Symmetry powers hundreds and hundreds of VMs in our cloud environment. Everything from Suite on HANA, S4 HANA, data marts, HANA deployed in a huge range of capacities in our cloud. We've been doing this with SUSE the whole way. They've been a great partner to us, so we've grown to really rely on and trust this operating system. Thanks for attending. Appreciate it. If anyone has questions, feel free to find me afterwards.
Yep, come and find Matt. Can you stick around for just a minute or two in case somebody has a question? All right. Matt, thank you. Let's give it up for Matt. Appreciate you coming to our booth one more time. You know the drill.
Yep, I know the drill.
We're going to give away some prizes based on the number that you're on the chair you're sitting on.